Hello everyone, so in this lesson we're going to see what happens when we increase the pressure. But first you need to understand what a pressure increase does. So if we have a container, and if you then take that container and make the volume smaller, then what happens is that the particles have less area to move about, and so they collide with the containers more often, and so that causes the increased pressure. So you must understand that to make the pressure increase, you must decrease the volume. Now if you look at this system over here and this system over here, both of them contain 6 particles. However, because this one down at the bottom has a larger volume, does it look more concentrated or less concentrated than this one? Well, it's going to be less concentrated because the volume is bigger. So a larger volume will give you a lower concentration of all of your particles. And so in this question we have a pressure that has been increased, which means that the volume has been decreased. Okay, so volume has been decreased because you've made the volume smaller, and so now the particles have less space to move, and that's why the pressure has been increased. So they should actually say here pressure is increased by decreasing the volume. So if you decrease the volume of your entire system, then what does that do to the concentration of the particles? Well, it makes the concentration larger, and that's for all of them. And so notice how all 3 of these particles, nitrogen, ammonia and hydrogen, have all spiked up. Now we need to see, according to Le Chatelier, how the system is going to respond. So we have increased the pressure, and so the system is going to try to decrease the pressure. So remember, it does that by making less gas. So if we look on the left of our equation, there is 1 plus 3, so there's 4 gas molecules, and on the right there is 2 gas molecules. So if you want to make less gas, then the forward reaction must be favored. So we will see the amount of NH3 increasing while the amount of N2 and H2 will decrease. And so we saw that all 3 of them went up. Why? Because if you make the volume smaller, then the concentration of everything goes up. Then, according to Le Chatelier, the system will try to decrease the pressure, so it went to the forward direction, so we make more NH3, so this goes up, whereas the other 2 decrease. Then we reach equilibrium again, where these 3 are parallel. Now we need to look at the rate. So we said in the previous lesson that if you increase pressure, concentration or temperature, the rate increases. So here we're increasing the pressure. So all we need to ask ourselves is which reaction will be increased the most? Well, because the forward reaction is being favored, that one will increase the most. So it spikes up. And then like I explained in the previous lesson, whenever we're dealing with a pressure or a temperature change, we will also spike the other one, okay? So let's just extend this a little bit, and then we can spike it up to there, for example. So you won't spike it the whole way, but you will at least spike it a small bit. And then what happens is that we will let this one settle down, and then this one will simply go and join it like that. And so what we can then see is that the original equilibrium position is at a lower rate than the new equilibrium position. And that is because we said that whenever we increase pressure, concentration, or temperature, then the overall rate of the system will increase.